Right, now we are doing polynomial, second last section. Not yet, but Matthew is going to read the book and tell us. Okay, we are doing factor theorem, so let's start factor theorem. Now, yesterday, before the lesson end, we talked about factor theorem, so let's recap. Factor theorem is talking about I divide by something and what happened to the remainder. Huh? There's no remainder, right? There's no remainder, and hence the birth of factor theorem. So, uh, so I would like to start by asking you to check if there's any remainder when I divide. So what will you do? Wrong. First step is not that. Xinghui, what will you do? Very good. Fx. So can you write the statement? Let what? Fx be equals to so write that. Near writing? No already. No. But if you don't write, then I don't know how to give you the next mark. So it's a leading step to the next step. Now how do I continue? What do I write? Let x plus 3 equals 0. Very good. Let negative 3 f what? Negative 3 equal remainder, right? F negative 3 equals remainder, right? Now this is an awkward statement. If you visit all textbook, usually they don't write this statement. But the reason why I write is because I want to remind you whatever comes out of it is actually the remainder. So let's try. Negative 3 square equals what? Plus what? Negative 3 minus 6. What's the answer? 9. 9. Oh, 0. Not 9. 0. So what can you conclude? Since remainder equals to 0, can you add this sentence and highlight? So I want to start to see this. I have my reason. Reason is because many times students just sub in the value. X equals to 2, the number. Then what is the number? Don't know. What does the number mean? Don't know. So I want you to know remainder equals to 0. And this is a very strong point. Because of this, hence what? Hence x plus 3 is a factor. And is totally divisible by x plus 3. So these two statements actually mean the same thing. Same thing. So same, sama. Meaning sometimes exam will ask you like in this way, sometimes exam will ask you in this way. But you need to know it means the same thing. It means no remainder. It means it's a factor. It means if I sub f bracket that number is equal to 0. Now let's start with example 7. Determine whether it is a factor or not. Start. Decimal is not a factor. Fraction also not a factor. Matthew can tell us what is the first remainder. Oh, first remainder is 0. Second remainder? 3. So I just want to check remainder equals to 0. Remainder equals to 3. Of course, this is a wrong presentation. But if I will leave part 2 blank, but basically it's exactly the same step. But the conclusion is since remainder is not equal to 0, fx is x plus 2 is not a factor of fx. Okay, go to the next page. Show that this is exactly divisible. What's the first step? No. What backward means what? You divide. You do long division. Can you do long division? Yes. Show you can do long division. Do long division and show. At the end, remainder is 0, hence it's a factor. Also can. But prone to careless mistake and prone to waste of time. So what do you do? Let what? Let what? Very good. So can you write down? Let gx equals, choose your favorite alphabet. Can. But I just want to show you that there's some variation, variety. Not every time must be fx. What do you do? Yeah, sure. Sure. Equals to remainder. G negative 1 equals to what? Put in. Remember all the brackets. Remember to use your calculator. And can I have that magic number? Really? Oh, thank you. How do you write? Since. See, it gets so boring because everything is the same. Remainder equals to 0. X plus 1 is the 1. Don't use x plus 1 as a factor, please. What do you write? X4 minus. So you repeat the question. Do you realize I'm very lazy? I repeat the question. Because that is exactly what you should do. Yes. Maths people are very lazy. That's why we invent all the different symbols to help us. Right. So change the statement. Don't use the factor. Use exactly divisible. Use the statement. It's how you show, then you write this statement. Follow. Okay? Right. Next one. Can I skip all the way already? Can I give you time to do already? Do properly and then I don't do homework, okay? Pause. Okay. Now, can I have your attention just for 20 seconds? Then I return you to your time. So I'll look up first. Okay. Now, given this is a factor, so this is a standard. When you write this, can you please write equal to 0? Because you know that it's a factor means there is no remainder. And when you write equal to 0, it becomes an equation. It's easier for you to do later. So some of you do all the way, then after that equal to 0. No, write equal to 0 first. Can write h bracket p equals 0? Can. Oh, this thing equal HP. Like that. Okay, Jiaxuan got a question. Can I write like that? No. Because HP means I need to. Actually, yes. You can write. But my point is, you write HP, right? You can't simplify, you can't solve this. Because HP is unknown. But 0 can solve. So I rather you write 0. So always have this statement start first. Then you continue from this statement. Just now I saw some of your work. Don't have equal to 0. You do this equal, then lastly equal to 0. Then like quite confusing, quite dangerous. So start with equal to 0 because this itself in exam is 1 mark. Even below all wrong, this itself in exam is 1 mark. So have this habit to write. Okay, stop, pause, continue.